السلام عليكم ورحمة الله وبركاته.
عليكم السلام ورحمة الله.
كيف الحال يا شباب؟
حياك الله يا دكتور، صباح الخير.
طيب نبغى دقيقة واحدة وحنبدأ إن شاء الله.
دكتور، المحاضرة الماضية ما سجلت في الرابط حق التحضير.
ما سجلت؟ على حال. السلام عليكم، بسم الله الرحمن الرحيم. نبدأ إن شاء الله لأن المحاضرة حتبدأ الآن، باقي دقيقة لسه. ولكن التحضير، بالنسبة للتحضير بتبع نفس الأسلوب اللي اتبعته المرة الماضية. فلما أفتح الموقع لازم تكونون عارفين بالضبط إيش قاعد تسوون، وتدخلون الموقع تسجل بسرعة. طيب طيب بسم الله الرحمن الرحيم. نبدأ. I will continue chapter 4 discussion, and we are slightly late, not too much, but inshallah from now will be things will be okay. طيب the last thing I talked about was strong acids, and I gave you this list of acids, and they told you to memorize these acids, very important acids, which are actually hydrochloric acid, hydrobromic acid, hydroiodic acid, okay, and the nitric acid, which is special group, which is HNO3, chloric acid, which is HClO3, and then perchloric acid, which is HClO4, and sulfuric acid, H2SO4. I want you to memorize these acids. Memorize these acids, which are written for you here. And here, of course, these are the acids: HCl, HBr, HI, HNO3, HClO3, HClO4, H2SO4. These are the strong acids, and these, when they decompose completely in water to give H plus and Cl minus, and that's why they give strong electrolyte. All of these are strong electrolytes. What's the meaning of electrolytes?
High electricity conductor.
Conduct electricity. You have to know this, and you have to memorize it. Good. All right. Other than these, even including HSO4 minus is a weak electrolyte. So why? Whenever you draw two arrows, this means this is a weak electrolyte. I want you to know, other than these, another acid, which I told you last time, and I'm going to repeat it.
Doctor,
Yes.
which of them the more strong?
All of them are strong. All of them decompose completely in water. Okay. All right. Now, what's this? What's the name of this acid? We sometimes write it like this. We can write it H2C5OH, and we can write it
Acetic acid.
Yes. C2. It is C2 CH3 C2 H3O2H. Okay. Actually, we always write like the CH3. That's the best way. See, I'm making mistake now by writing it not this way. The CH3CO. Okay, so I want you to memorize it like this. What's the name of this acid?
Acetic acid.
Acetic acid. And all the organic acid, anything in the organic compound that contain COOH is considered to be weak acid. Weak acid. So when you want to make it decompose, you should write 2 arrows, CH3COO minus plus H plus. Why did I write 2 arrows?
Because it's a weak electrolyte.
Weak acid. Weak acid means weak electrolyte as well. All right, good. So these are the acids that you must memorize as strong. This one is the weak electrolyte. Good. Next. See, this is the acid. This is acetic acid. And as I said, I always memorize the structure, but the more important structure is COOH. And any compound, any organic compound that contain this group is considered to be acid. I'll give you another example. For example, if I say CH3, CH2, COOH, you don't have to know what's this acid, but once you see this group, what does that mean?
Weak acid.
Weak electrolyte.
Acid. Weak acid, and also weak what?
Electrolyte.
Weak
Electrolyte.
electrolyte. This is propionic acid. For your information, you don't have to know it. Okay, good. Of the bases, if we have the most important base that you should know, the weak base is this base. What's the name of this base?
Electrolyte.
Amine.
Ammonia.
Ammonia.
Ammonia is a weak base. Weak base. This is ammonia. It's a weak base. Okay. Any organic compound that contain I draw 2 electrons because all right. Anything that contains nitrogen is considered to be weak base. And of course, weak electrolyte. Weak electrolyte. Is this clear? So this is the weak electrolyte of the bases. If it is ammonia or any organic compound that contain what?
Nitrogen.
Nitrogen. NH2 or NH, even if I write, for example, CH3, CH2, NH, C2H5. There's also a weak base. Anything that contains nitrogen is considered to be weak base. Weak base. Good. This is the difference between non-electrolyte this is weak electrolyte and this is strong electrolyte. What's the difference?
Conductivity of
conduct electricity. You cannot see any light here. Weak electrolyte, you can see light, but it's not strong. But when you have strong electrolyte, it will conduct the electricity very strongly, like so. Okay. Any ionic compound, when it dissolves in water, like for example, sodium chloride. What will happen if you put sodium chloride in water?
dissolve, disappear.
It'll be what? Na plus and Cl minus. Okay. Why we call this ionic compound?
Because it have two ions.
Because it has cation.
One is metal and one is non-metal.
Metal with non-metal, cation and anion. Okay. All right. So what do we call this compound?
Ionic. Oh, okay.
What do you call this compound? Molecular compound.
Molecular, yes.
Compound. Does it conduct electricity?
No.
No.
Non-electrolyte. Good. But this one is strong electrolyte. Good.
Doctor, I didn't realize the difference between strong and weak electrolyte.
If it decomposes completely, then it is strong. Why this is strong electrolyte HCl? Because it gives you fully, look at the arrow, I draw one arrow. What does that, what the meaning of one arrow? Complete.
Okay.
Complete dissociation. What is the meaning of two arrows like this?
Weak.
10% decompose, 90% stay like this. So only very little decompose. These ions will conduct electricity and this will be weak electrolyte.
Okay.
Good. Now we have this table. If you have any compound, if you want to know if it's strong electrolyte or weak electrolyte, ask yourself the first question, is it ionic? If it is ionic and dissolved in water, then it will be always what?
Strong electrolyte.
Strong electrolyte. If it's ionic and dissolved in water. Okay, give me example quickly.
NaHl, Cl.
NaCl, or anything like, for example, calcium bicarbonate. You have to memorize the group. Calcium bicarbonate, dissolve in water and will conduct electricity. Are these going to be strong or weak electrolyte?
Strong
electrolyte.
Strong electrolyte, all ionic compounds. Now, molecular compound means not ionic. You should ask yourself, is it acid or base or neither? Okay. If it's acid, then if it is one of the strong acid, then I gave you here one of these seven acids, then it will be what? Strong electrolyte. If it's one of the seven acid, one of seven acid. If it's other than that, like acetic acid or things like that, then it will be weak electrolyte. Give me example of strong electrolyte. Strong acid electrolyte.
HCl.
HCl, other. HBr, other. HI.
Nitric
else?
acid,
Nitric acid, HNO3. What else?
chloric acid,
Chloric acid. What else?
perchloric acid,
Perchloric acid. You have to memorize these. And the last
sulfuric
one,
acid,
sulfuric acid. These are the strong. I want you to memorize these and memorize them very well. Give me example of weak electrolyte, which is acid.
sulfuric
Acetic.
acid minus,
Acetic.
Acetic acid. Anything that contain this group is considered to be what? Weak acid.
Doctor, do we name this group carboxylic acids?
Carboxylic acid, yes. These are carboxylic acids, yes. Good. Now, if it's not acid, then it will be base. Also, if it's base, then it will be weak base. Give me example of weak base.
That contain nitrogen.
Ammonia.
Ammonia or any organic compound that contain
Nitrogen.
nitrogen. In these are considered to be weak bases. Okay, are they going to conduct electricity?
No.
No.
Yes, but
Conduct weak electrolytes, which are weak electrolytes. Is this clear? Last thing, if it is neither acid nor base, then it will be non-electrolyte. Give me example. Sugar. C6, H12O6. Other example.
CO2.
C3OH.
H2O.
CO2 is also, yes, but it is, in this case, yes, CO2 is another non-electrolyte, of course. All right, good. Very quickly solve this problem. A, is it electrolyte or non-electrolyte? Or weak electrolyte or strong electrolyte?
weak.
None.
Weak.
Weak electrolyte.
None.
Not electrolyte.
Why?
Because it's
Because
not
neither
base
Nick,
of
neither acid.
Because it is here. It is neither acid nor base. It contains only OH. So it is neither. Non-electrolyte. That's OH. Is this clear? Good. Next, NaOH.
None. Or strong.
Strong electrolyte.
Why strong?
Because has
Ionic.
acid and no.
Ionic.
I think.
It is ionic compound. If it is ionic compound, then it will be strong electrolyte, ionic compound. Good. Okay. How about this one? Ethylamine.
Weak.
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 Why?
Contain
Because
nitrogen.
there is nitrogen.
Is organic
Nitrogen
and
base.
contains
Right.
nitrogen.
Because it's a what? Weak
Nitrogen base.
base. Contain nitrogen. That's why it's weak base. Exactly. Okay. Hydrofluoric acid.
Strong.
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 Not strong with
Why weak?
because it is
that-
not
It's
acid.
acid.
It's not in the list.
It's with yeah.
The 7 acids that I told you, these are the strong. The rest are not strong. So HF is not a strong acid, weak acid. Weak electrolyte. And
It's
weak.
not in the table.
Yes, not in the table,
Okay.
which I told you to memorize. You have to memorize the table. Good. Done with these.
Doctor, what do we mean by base?
The S,
Base. What do we mean by base?
anything that contain base is actually anything that contain We'll talk about bases later in this chapter, but anything that contain N group is considered to be weak base. I'll talk about weak base, a strong base in the next slides. Okay, anything that contain N is considered to be weak base. Anything that contain OH, like this compound, these are bases, but these are strong electrolyte. Why? Because these are ionic. So these are bases. We will talk about acids and bases in a short time. Okay, good. Next, we will talk about solubility. What's the meaning of solubility?
Being able to dissolve.
Dissolve in water. Okay, we want to see which compound dissolve in water of ionic compounds. If we have ionic compounds, we want to see if it dissolves in water or it doesn't dissolve in water. For example, if you put NaCl in water, what will happen?
Na plus.
It will dissolve in water. It will be Na plus plus Cl
minus.
But if you put calcium carbonate, which is part of the sand, if you put it in water, what will happen? It will stay as calcium carbonate solid. If you put calcium carbonate in water, it will always stay as calcium carbonate, not
even with its ionic compound.
It is ionic compound, but it does not dissolve in water.
Okay.
All right? But this one dissolve in water and give you aqueous Na plus and Cl minus aqueous and dissolve in water. But this one does not dissolve in water. We want to learn now which one will dissolve in water and which one will not dissolve in water. Is this clear?
Yes.
So, Doctor,
the
second compound is not electrode.
What?
The second compound in the previous bed is not electrode.
Electrolyte.
Electrolyte.
Let me ask you a question. CaCO3, is it electrolyte or non-electrolyte?
Yes.
What?
It is electrolyte.
Because it's
non-electrolyte. Ionic and
electrolyte. Why?
Not with the table, not ionic.
Not ionic. There's no ions. No ions. If there's no ion, it will be non-electrolyte. This one, is it electrolyte or non-electrolyte?
Yes.
Yeah.
But because it's not this ionic, you told the ionic always strong.
Yes, I told you the ionic when it dissolves in water.
Oh, okay.
If it doesn't dissolve in water, then it will not be strong. It will be none. Clear?
Okay.
Okay. What's the meaning of precipitate? Precipitate means come out of water. Example, if you put sand in water, what will happen?
Nothing.
Stay in the bottom.
It will precipitate. What's the word?
Precipitate.
Precipitate. Okay? If you have a reaction, for example, if I give you a pot here containing, as I told you, don't forget, I just gave you two examples. Keep them in your mind. If you put NaCl in water, what will happen to it?
They will dissolve.
will dissolve.
But if you put calcium carbonate in water, what will happen to it?
Stay.
It will not dissolve.
It will precipitate, and we can write PPT means precipitate. Precipitate. But this one, aqueous, means it will dissolve. Clear? Good.
Okay.
If I put two pots here, this one and this one. In the first one, I put calcium chloride, calcium 2 plus and Cl minus. And on the other one, I put sodium carbonate, sodium plus, CO3 2 minus. And these are all dissolving in water, sodium carbonate and calcium chloride. But if I mix these together, took this one and pour it here, this means I will pour it here, then what will happen? Mix them together. I mix the two, I mix these together. What will happen? Na will stay as Na plus. Cl minus will stay as Cl minus. But calcium and the carbonate will come out as calcium carbonate solid. They will come out of the solution and precipitate like this. Clear? We call this precipitation reaction. Precipitation reaction. Is this clear?
Yes.
Sir, isn't sodium more powerful than calcium? Why it's still dissolved?
Oh, we will learn what dissolve and what not dissolve. This is what will happen exactly when we put sodium chloride, or in this case, we have this example here, lead nitrate. So on this side, we have lead nitrate, and lead nitrate dissolved in water, and you can see that it is completely dissolved. Sodium iodide. Sodium iodide in here, and lead nitrate in here, and both of them dissolve in water. But when we mix them like this, what will happen? Lead will come out with iodide. The yellow thing here is actually PPI coming out as precipitate, and now it is complete precipitate here, while sodium nitrate, Na and NO3, will stay in solution like this. Okay, this is called precipitation reaction. Now, when you take anything and dissolve it in water, like for example, if we take sodium nitrate and you dissolve it in water, what will happen? You're going to have Na plus plus NO3 minus, and actually what will happen then? You'll find that the Na plus is surrounded by water molecule. If this is water molecule, each one is H2O, and the NO3 is surrounded by the water molecule to hold it inside. This is called hydration. Hydration. Example, like this example. See, this is hydration. That's the positive ion is surrounded by water, and the negative ion is surrounded by water. What's this process called? What's
Hydration.
Hydration. But if anything comes out like this one, the yellow took the white from somewhere else and came out of solution, what do we call this? Precipitation. Precipitation. Clear? Precipitation. Now, we want to learn what will dissolve, what is soluble. Soluble means dissolve. Soluble means dissolve, same meaning. We want to learn what are the ionic compounds. We're going to talk about ionic compounds. Ionic compounds. What do you mean by ionic compound? Contain cation and anion.
Anion.
What's cation?
Plus one.
Positive ion.
Positive.
It's usually metal.
I think most of the time, of course. But anion means
Minus.
negative.
Or negative, I mean.
Negative ion. Good. Now, we want to see which compound will dissolve in water and which compound will not dissolve in water when it is ionic compound. Now, look at this table. Again, I want you to memorize everything in this table. Everything in this table you must memorize. What's the first rule? Any compound that contains lithium, sodium, potassium, rubidium, cesium. Look at your periodic table. What are these elements?
First group.
Alkyls.
Alkali. Alkali ion will dissolve in water. Also NH4. So any compound that contain alkali metal or NH4 group, what's the name of this group?
Ammonium.
Ammonium ion will dissolve in water. Very simple question. Sodium H3COO minus. What's the name of this compound? Sodium acetate. Sodium acetate. Is this going to dissolve in water?
Yes.
Why?
Yes.
Because it has
Contains alkali.
Because it contains what?
sodium.
Sodium. It contains sodium means it will dissolve. Okay, how about this one? Rubidium sulfate. Is it soluble in water?
Yes.
Yes, because it has rubidium.
Rubidium alkali ion, then it will dissolve in water. Good? Is this easy?
Yes.
Next, any compound that contains nitrate will dissolve in water. For example, if I tell you calcium nitrate, is this going to dissolve in water?
Yes.
Why?
Because it has
the nitrate ion.
Iron. All right. Okay. Anything that contains acetate ion will dissolve in water. Anything that chlorate will dissolve in water. So when you see these ions, as I said, nitrate, acetate, and chlorate will also dissolve in water. Good example. For example, we said sodium acetate. Is it going to dissolve in water?
Yes.
Why? Because it contains what?
Acetate ion.
Contains sodium plus and acetate, all soluble in water. How about if I say calcium pH? Wise. Calcium acetate, is it going to dissolve?
Yes.
Why?
Because it contains
acetate.
Acetate. Okay. How about AgClO3? What's the name of this compound? Silver chlorate. Silver chlorate. Is it going to dissolve in water?
Yes.
Why?
Contain chlorate.
Contain chlorate ion.
Good. Next, compound containing chloride, bromide, and iodide. Look, there is no fluoride. Be careful. What's the name of the compound? Chloride, bromide, and iodide. Halogens. Halogen.
Halogen, yes.
Halogen, but without
fluoride.
no fluor, no F. These are also will dissolve in water, okay, except when they come with this ion. Then they will not dissolve in water. Okay, so if I write lithium chloride, is this going to dissolve in water?
Yes.
Why? Because it contains
It's
chloride.
containing chloride with lithium. Lithium is not.
both are soluble. But if I have a GCl, is it going to dissolve in water?
No.
Oh.
Why not?
No.
It's exception. Exception.
Hey.
3 ions you must memorize. What are the ions?
Silver and
Mercury.
Not mercury 2, mercury 1, which is special group, and
lead.
lead. You must memorize this. Good. Next, compound containing sulfate ion, SO4 2-, is also soluble in water. But there are exceptions. What are the exceptions? What's this?
Silver.
Silver.
What's this?
Mercury 1.
Mercury 1.
1. What is this?
Lead.
Lead.
Similar to these, right? But in addition also, what's this?
Calcium.
Calcium 2+. Strontium Ba. Where are these elements?
The earth. Alkalium.
Second group, alkali.
Alkaline earth. Alkaline earth. But look, starting from what? Calcium. How about Mg?
No.
It will be soluble. It will dissolve. Is this clear?
Doctor,
Yes.
do the lead have two and
Two ions. Yes.
+2 and +4?
Yes.
So
But
+4 with +4 will it dissolve or not?
Yes, +4. Very good question. +4 will dissolve. +2 will not dissolve. +2 will dissolve. Excellent question. Clear? Good. So if I have Na2SO4, is it going to dissolve in water?
Yes.
Yes.
Because of SO4 with Na, it will dissolve. But if I have Hg2SO4, is it going to dissolve?
Insoluble.
No.
No.
Insoluble. Why?
Because
Mercury.
Mercury 1. Is this clear? I hope so. Now, these are water soluble. All of these are going to dissolve in water, and these are the insoluble exception. Clear? You have to sit down, memorize this table. Memorize it very well. I hope so. Good. Now, on the other hand, in this table, these are insoluble in water. Compounds that are what? Will not dissolve in water, and these are exception. Okay? Any compound that contain carbonate or phosphate or chromate or sulfide are insoluble in water. Exception if we have lithium or sodium or potassium, rubidium, cesium. What are these elements?
Alkali.
Alkali.
Alkali. What's this?
Ammonium.
Ammonium. Okay. With hydroxide also, things will not dissolve except if there is lithium, sodium, rubidium, cesium. What are these? What's the name of these compound?
Alkali.
Again, and also in addition to this, only Ba2+ from the alkaline earth. The last one. You have the Tipperary table with you. Barium is at the bottom of the alkaline earth. Others will not dissolve in water. So these are insoluble in water. So if I give you calcium carbonate, is this soluble in water?
No,
No.
Why?
because it is here, yeah, the table.
Contain carbonate. All right? Contain carbonate. Okay. If I have FeCO4, what's the name of
No.
this compound?
Iron phosphate.
Iron phosphate.
Iron phosphate.
Iron 3 phosphate. Is this soluble in water?
No.
Why?
Contain phosphate.
Contains phosphates.
Iron is not on the table.
Contain phosphate. Clear? All right. How about if I have K2CrO4? What's the name of this
Soluble.
compound? It's called potassium chromate. Is this soluble or not soluble?
Soluble.
Chromate is supposed to be not soluble, but K2CrO4 is what? Soluble. Why?
Exception.
It contains K+. Is this clear? You
Yes,
have
yeah.
to sit down today, memorize these two tables, for table 4.2 and table 4.3. They are very easy to memorize, very, very easy. You can memorize them in less than 3 minutes. Believe me. All right?
Doctor, I have a question.
Yes.
If I have a compound contains, for example, K+, is it possible to, in some cases, I mean يعني ممكن إنه ما يذوب في المويه مثلا؟
Always dissolve in water. The first rule, all soluble. Anything that contains K+ is soluble. Clear?
Clear, thank you.
Next. Now, from the table, probably you have the table with you, but you don't have it. Is this soluble in water or not?
The first one, not.
No.
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 Rule. Second
Because
rule
it's contain
It contains nitrate.
is what?
Soluble.
Is soluble or not soluble?
Yes, soluble.
Soluble.
Soluble. Okay. Calcium sulfate. Is it soluble or not soluble?
Soluble.
Soluble.
Is it sulfate? Is it soluble or not soluble?
Not soluble.
Not soluble.
Soluble.
Because
Why?
it contains
It
calcium.
contains calcium.
Because it has calcium. So yes, this is not non-soluble. Next one. This one, K2CO3.
Soluble.
Soluble.
Soluble. Why?
Contains K.
Contains potassium.
Next. If we have a reaction like this one, all right, what will happen? PPNO3, is it soluble or not soluble?
Soluble.
Why?
NO3.
Because it contains nitrate, so this is soluble. And this one, sodium iodide.
Soluble also.
Why?
Has sodium.
Sodium and iodide dissolve with sodium. All right? When we have in one pot PPNO3 and in the other pot we have NaI, everything is dissolving in water. You will not see anything. But when you mix them together, what will happen? The PP will see the iodide and will come out of solution. So what will happen? The sodium will stay in solution, the NO3 will stay in solution, but the PP with the iodine will come out as PPT. That's why PPI2 will come out as solid, while NaNO3 will be aqueous, it will dissolve in water. What do we call this equation?
Precipitation reaction.
Precipitation reaction. Precipitation reaction. Precipitation reaction. Clear? Very good. Let's have another example. If we have sodium sulfate, Na2SO4, is this soluble in water or not? Sodium sulfate.
Yes.
Is it soluble?
Soluble.
Yes.
Why?
Because it has sodium.
It has sodium.
Sodium. Okay. Barium hydroxide. Is it soluble or not soluble?
No.
Yes, it is. Look at this. Hydroxide are non-soluble, insoluble.
Oh, okay, okay.
But contain what?
Contain barium.
But this special case. And so barium chloride is soluble in water. When you put them together, what will happen? Barium will see the sulfate. What will happen?
Will react with
Will come.
Barium with the sulfate.
Will be the bit.
And what will happen to sodium with OH? It will be 2NaOH. But we write here aqueous, and we write here aqueous, and we write here aqueous. Why did I write aqueous here?
Because both of them are sulfate.
The compound dissolved in water. This compound dissolved in water, it's aqueous. This compound dissolved in water, it's aqueous. But this compound is precipitate. We call the first equation molecular, write this name, molecular equation. What's the name?
Molecular
equation. We can make this equation as ionic equation by making everything is ion. Look at NaSO4, I made it 2Na plus and SO4 2 minus. Everything is aqueous, dissolved in water. Barium was barium 2 plus aqueous plus OH2 minus. This is called also the aqueous dissolved in water. And then NaOH dissolved in water. Na plus and 2H minus dissolved in water. Aqueous. But BaSO4 is solid, will not dissolve in water. We write this equation like this. So it's the same equation. What do you call the first equation?
molecular equation.
What do you call the second equation?
Ionic
equation.
Doctor?
Same equation, but instead of making it molecules, we make it ionic compounds. Clear?
Doctor,
Yes.
repeat the last step, please.
I repeat one more time. We are repeating a chemical reaction. The chemical reaction. First time, I wrote the whole compound, Na2SO4 plus BaOH2 to give you 2NaOH plus BaSO4. And I wrote here aqueous. What do I mean by aqueous? Aqueous. What does it mean?
Dissolve in water.
But what did I write here? Solid. S.
Yes,
What
sir.
solid means?
Participate.
Yes.
Precipitate will come out of solution. Clear?
But why, Doctor, said?
Because we said that sulfate will not dissolve in water. Calcium sulfate will not dissolve in water. Is it calcium or what that will be? Oh, PP. Oh,
Doctor, why Be here is aqueous?
soluble. Yeah. Oh, barium is not soluble, yes. Sulfate, barium is not soluble.
Yeah,
Okay.
clear.
What do we call this equation? What do you call the first equation?
molecular.
Don't forget the name, molecular equation. We can write everything as ions instead of compound ion, like this, like this, like this, like this. And then this will be also ion because it dissolves in water. But barium sulfate will be solid. Clear? What do we call this equation? The second equation.
Ionic.
Ionic equation. Don't forget. Clear? Next.
دكتور يعني إذا حفظت الجدول اللي هناك راح أعرف العناصر اللي بتسوي precipitation.
Yes, exactly. Okay, good. What do we notice here? Look carefully at the ionic equation. There are 2 Na plus, right? And 2 Na plus in the product. We can cancel the reactant and the product. What else you notice repeated in the reactant and in the product?
2OH.
OH barium.
And
2 hydroxide.
What else is repeated?
Hydroxide.
Nothing. So
Nothing else. Yes.
Which is SO4 2 minus plus Ba 2 plus to give you Ba SO4 solid, and this is of course aqueous, and this is called aqueous. What do we call this one? We call it net ionic equation. Net ionic equation. Is this clear? Is this clear? I hope so.
Why net, Doctor?
Net total means total, because if anything that is repeated, we'd cancel it. Sodium cancelled here, and OH is cancelled here and here. Is it clear?
Yes.
We call the sodium and the OH, which is available in both the reactant and product, what do we call them? We call them spectator ion. Spectator, smart spectator.
Just watch.
Yes, spectator means just watch. All right, good. And what do you call this equation?
Net equation.
Net ionic equation. Don't forget the word spectator are those ions which are repeated in reactant and product, which we are going to cancel. These are called spectator ion. Spectator ions. Good. Now, let's write this equation very quickly. We want to write, first, let me ask you, lead acetate, is it soluble in water or not?
Contains.
Yes, it is.
Why?
It contains PP.
No, it contains acetate. Yes. Contain what?
Acetate.
Acetate means soluble. Soluble. Clear? So, is this soluble or not soluble?
Soluble.
Soluble.
Yeah.
How about calcium chloride?
Soluble.
Soluble also. Soluble. Now I want you to write a molecular equation to show me what will happen. I want you to write the molecular equation, which is PbC2H3O2. Everything is 2 reacting with calcium chloride. What will happen? Don't forget, chloride, everything is soluble, but if it sees lead, let's go back to the table. Chloride with Pb2+, what will happen?
Well, not so.
Soluble. Good. So let's write this equation. What will happen if you mix this one with this one? This is aqueous now,
solid.
and this is aqueous. So what will happen? We're going to have what? Calcium.
The lead will react with the
Calcium C2H3O2 twice, plus what? This is aqueous also. And plus what?
PB chloride.
ECl2 what?
S.
Yes.
Solid. Solid. All right? Solid. And that's why actually we're going to have it like this. It's already balanced. What do you call this equation that I just wrote?
Molecular.
Molecular.
Molecular equation. Can you write ionic equation?
Yes.
Go ahead.
Yeah.
Write it yourself. Quickly.
Ca plus 2 and CH3O2
BB2
minus
plus
1.
BB2 plus. Plus.
Plus 2C2H3O2.
O2 minus. Plus.
Ca2 plus.
Plus.
2Cl minus 1.
To give you what?
2
plus. Plus. 2 C2H3O2 minus. Plus.
BPCl2.
BPCl2, no change. Clear? Very good. All right. What do you call this equation, the second equation?
Ionic.
No, yes, sorry. Yes,
Ionic.
ionic. Where are the spectator ions?
PP.
Ca
no.
and
Everything except PP and Cl.
Exactly. Ca is spectator ion. Ca is spectator ion. What else?
2C2H3O2.
Spectator ion. Acetate is spectator ion. Can you write the net ionic equation now?
Pb plus 2Cl equals to PP.
Plus 2Cl minus to give you PbCl2 solid. This one aqueous. This one aqueous. Can you do it?
Sir, in the ionic equation, why we didn't change why we didn't split the Pp and the Cl2?
Because everything was alone by itself before reacting. Okay.
Alone, you mean like what?
Because they were in the first pot, there's a Pp with acetate, and the other one was calcium with chloride. Everything was separated. When we mix them together, then the Pp with the chloride will come out of solution.
Oh, okay, I see, yeah.
Good. Very good. Next, we're going to talk about acids and bases. Acids and bases. Okay? And I'll give you two names you must remember. Arrhenius and Bronsted. Okay, these two scientists, I want you to memorize the name of the scientist. The first one is called Arrhenius, and the other one is Bronsted. Define what's acid and base. Arrhenius says anything that gives H plus in water is called acid. Is this acid?
Yes.
Yes.
What?
Because it gives H plus.
Clear? Very good.
Yes.
Acid. Base, anything that gives OH minus is a base. Is this base?
Yes.
Why?
Because it
Oh,
gives
it's
Gives
OH.
OH minus.
So I want to very quickly define what's acid by Arrhenius.
It will give H plus of
Anything give H plus.
It will give what?
H plus.
H plus. It's called acid. Okay? What's the base?
Oh, H minus.
What? Is this clear? Good.
Doctor, we
Now,
take this in chapter 2.
maybe we took it in chapter 2, yes. But I want you to memorize the name of the scientist as well now. Arrhenius and Bronsted. Okay, next.
Doctor, the base, how can we know it by Arrhenius?
The base, anything that contain OH. Now, Bronsted. What does Bronsted say? That anything that give H plus is acid. But he write it differently. He said HCl plus H2O will give you H3O plus Cl minus. All right? So he says that the H will go to the water, and the thing that will give the H plus is considered to be acid. So is this acid?
Yes.
Is this clear? Anything that give H plus is acid. It gave the acid to this one. But he says anything that take the H plus is called base. So anything that take H plus base. Clear?
Doctor, could you write an AOH in Bronsted way?
On what? No, just a second. We'll come to this. Okay, good. This is called acid, and this is called base. Why? Because the H was gone from here to here. So the one that give the H is acid. The one that give the base is the one that accept the hydrogen. So this give H plus, and this one what? Accept H plus. Clear? And he called this conjugate.
Doctor.
Conjugate base, 1 second, and this is called conjugate acid. Why? Because the conjugate acid, if there is any reaction here, if this goes back, the hydrogen will go from here to here. So in this case, also, this is the conjugate acid, and this will be a conjugate base. Okay, so I repeat one more time. Good.
Doctor.
So this is called now, anything that give H plus is called acid. Anything that give except H plus is called base, and the one that is formed from the acid is called conjugate base. Base. See, the Cl minus come from HCl, it become conjugate base, and the OH become conjugate acid. Let me give you a very quick example. Okay, according to Bronsted, what's this?
H2O is acid.
Acid.
Why?
Acid.
Give
Gives H plus.
H plus, exactly. What's this?
Base.
Base. What's this?
Conjugate
Conjugate
acid.
Now it become acid. Yes. What's this?
Conjugate base.
Conjugate base.
Base. Why? Because if the reaction goes back, the H plus will be given to this one from an H4. Is this clear? That's why now this become acid and this become base. I hope this is clear. I want you to memorize these, the definition of acids and bases according to Arrhenius and according to Bronsted.
Doctor.
Of course, we know the strong acid, we took them before. These are the strong acid. Did we see them before?
Yes.
Yes. HCl, HBr, HI, HNO3, chloric acid, perchloric acid, and sulfuric acid. These are the strong acid. On the other hand, the strong bases, according to Arrhenius, are the alkali and alkaline metals.
Hydroxide.
Sodium, potassium, yes, rubidium, cesium, calcium, strontium, barium. These are the alkali and these are the alkaline. But one is missing. Which one is missing?
Hydrogen.
Floor.
Magnesium.
Mg not here. Clear?
Yes.
So Mg should be here before calcium. If you have periodic table, look at the periodic table. These are strong bases. This one is weak base. And we know other, can you give me other weak bases? Yes? NH3 is a weak base, you remember?
Yes, doctor.
Is this weak base?
Yes, it contains hydrogen. Nitrogen.
Organic compound contain nitrogen, yes. Very good. So we know the strong acid and the strong bases. Okay, good. We define, this is now according to Bronsted, acids and bases. Is this acid or base?
Base.
Base, exactly. What's this?
Acid.
Acid.
What's this?
Acid. Conjugate acid.
Conjugate acid. What's this?
Conjugate base.
Conjugate base. Very good. How about this one?
It's a base.
Acid.
Base.
But doctor,
Just a second. What happened here?
The hydrogen.
Acid. Acid.
3O.
It gives H.
So this means what?
Acid.
Acid.
This one.
This is acid.
Base. This one.
Conjugate.
Conjugate acid.
Acid. This one.
Conjugate base.
Conjugate base.
Base. Okay. Now, what's this? Is this acid or base?
Acid.
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 Because it gives hydrogen.
What's this? Base.
Base.
Where is the conjugate base? Conjugate acid. NH4 plus.
NH4.
Plus is the conjugate acid.
And this.
Still minus.
Sir, H2O is base or acid?
H2O?
Yes.
What's H2O here?
Liquid.
What is it?
Acid.
How about here?
It is base.
So it could be acid or base. It depends on
So-
the reaction.
If
okay.
if it's give hydrogen, then it's acid. If not,
Exactly.
space.
Exactly.
دكتور
يا شباب حطوا ميوت.
دكتور
Monoprotic, I want to define this and we'll come back. Monoprotic means give one hydrogen. HCl is monoprotic acid. Diprotic means two hydrogen. H2SO4. Triprotic, what does it mean?
Three hydrogen.
Three hydrogen.
Three.
Polyprotic means what?
4 and more.
More than one. Two or more. Anything H,
Okay.
N, HN, and then X is N equal to or greater than 2 is called polyprotic. Polyprotic. Clear? Now, always when things dissolve, the first hydrogen is very strong or stronger than the second one, definitely. Look, when H2SO4, when we write 1 hour, what does it mean?
Strong acid.
Strong acid.
Complete reaction.
Complete
strong acid, exactly, it is strong acid. When we write 2 hours, what does it mean?
Not 10%.
Not, this is less than 10%.
90. Yeah.
Less than 10%. And this one 90% or greater than 90%. This means it's going back and forth. Good. When you have weak acid like H3PO4, this is phosphoric acid, it's weak. This is the first proton, this is the second proton, this one is the third proton. Which one is the stronger? Is it the first proton or the second proton or the third proton? Always is stronger than the second, is stronger than the third. And that's why the H plus in H3PO4 is stronger than the H plus in these ions altogether. All right, so always the first hydrogen is stronger than the second and then the third. So this acid, which one is stronger acid? H3PO4 or H2PO4 minus or HPO4 2 minus. Which one is stronger?
The first one.
The first one is stronger. This is weaker and this is the weakest. How about PO4? 2 minus. This is not acid anymore. This is now become what? Base. Very weak base. Good. So if we have polyprotic acid, always the first hydrogen is stronger than the second, stronger than the third. Now, when you react acid and base, acid, this is general rule, acid plus base, this is according to Arrhenius. The scientist Arrhenius. If you react acid with base, what are you going to get? Example, HCl plus what? NaOH. What's HCl? It's acid. Why?
Because it will give hydrogen.
This will give what?
Will give NaCl.
NaCl plus?
Plus water.
Water. Is this clear? All right. Let's do that. So this is equation, the first equation. We're going to call this now molecular equation. Okay. How about second equation? What do we call it?
Ionic.
Ionic equation. Why? Because we made everything as ions. So this is ionic equation. Clear? Where are the spectator ions here?
Cl.
Cl
and
minus
Na.
and Cl minus. What else?
Na.
Na plus and Na plus. And then what will be left? H plus OH
H
minus.
plus and O.
To give you what?
Water.
This is the net ionic equation for any strong acid, strong acid, strong base reaction. We don't have to say what's the acid or the base. The net ionic equation will be like this. This is the net. For any strong acid with plus strong base reaction, the net ionic will be H plus OH minus to give you H2O. I hope this is clear. Is it clear?
Doctor, I have
Yes.
a question.
Yes.
Do the strong bases conduct electricity?
Sure. Ionic compound. It's ionic compound, so it will conduct electricity. All right. Here. Next. When we have more than one compound, then when we have many compounds, okay, when any element lose electron, F goes to plus electron, go to F minus plus, okay, to give plus F minus. When sodium goes to Na plus electron. All right? When we have any element lose electron, we say this is oxidation. When any element gain electron, we call this what? Reduction. Clear? So,
Doctor,
what?
time is up.
Yeah, 1 minute. No, I'll stop at 1 minute. No problem. Oxidation reduction. Look at this. Zinc goes to zinc 2 plus 2 electron. What's this now called? This is called oxidation.
Oxidation.
While Cu2 plus will take the 2 electrons and it will go to Cu. This is called reduction. So I want you very quickly, what's the definition of oxidation?
Losing electrons.
Exactly. Lose electron. What's the definition of reduction?
Gaining
electron. Now, when they are together, this is now what happened to the zinc. The zinc is oxidized, right? Because of the oxidation, right?
Yes.
But zinc is reducing agent. What do I mean by reducing agent? Because zinc reduce copper. The 2 electrons come from zinc to go to copper. That's why zinc is oxidized itself. It loses electron. But zinc is reducing agent because it reduces copper. Is this clear? While copper, what happened to copper? It has been reduced. Copper reduced. But at the same time, it is what?
Oxidation agent.
Zinc agent. Agent means عميل. عامل أو عامل هو تسبب في الريدكشن، وهذا تسبب الايجنت تسبب في الاكسدايزنج اوف زنك. Okay, I will stop here and see you inshallah Wednesday. مع السلامة.
Doctor, what about the attendance?
Oh, I forgot to take the attendance. Okay, let's take the attendance very quickly. Sorry.
People are leaving, doctor.
What?
People leave.
Doctor, some of them leave
Because we have a class.
because they have classes.
خلاص. Sorry. I forgot about the attendance. Sorry. خلاص next time.